the Fourier series application in circuit analysis. A RC circuit we have seen, and then we have found the output voltage parameters, right? So in that case, we have seen that the output voltage is also dependent on the circuit parameters because it may some angle difference from the output voltage Fourier series, you can see. And the very interesting thing is that the amplitude of each harmonics by the times of number of harmonics, because it, right, the
Yes, sir.
Fourier that we have seen, the Fourier that you can see, the Fourier fundamental has 32.2, but third harmonics has 4.16, fifth harmonics has 1.516. So the amplitude is getting down, although their frequency with that number of frequency. So at the end, we can say that nth order harmonics is totally ineffective. That's why we don't calculate more than 11 or 15, but it depends on the number, it depends on the application also. Other thing is, so today we are going to start the new topic, that is a frequency spectrum. The frequency spectrum is a representation of amplitude and frequency of the signals, you can say. So from that diagram, we can easily see what are the trend of the harmonics in the desired signal, or what is their amplitude respect to the frequency of a signal. That's why we need to draw the frequency spectrum. In frequency spectrum, the x-axis will be frequency and y-axis will be the amplitude. X-axis will be frequency, y-axis will be amplitude, and the respective coefficient of the given, or the respective maximum value of the given frequency should be drawn in that diagram. That is the frequency spectrum of a signal. Such as, here is one example in slide number 8. We have done earlier a square wave DC signal. Square wave DC signal. This one. Square wave DC signal. So what is the frequency spectrum of this signal? We have represented it here. So as we have done the Fourier series in our last slides, we know is E by 2 plus twice E by pi sine omega t plus twice E by 3 pi sine 3 omega t plus twice E by 5 pi sine 5 omega t, and so on. Hence,
Yes, sir.
it has the DC value plus odd, the fundamental plus odd harmonics. So the drawing will be omega, you have drawn the omega, twice omega, 3 omega, 4 omega, 5 omega, and so on this way, and draw the respective frequency. Here you can see the E by 2 place. That means the DC value, then DC value frequency is 0. So this amplitude has been drawn on the 0 frequency.
Yes, sir.
Next term coming, the sine omega t,
Yes.
that means single omega, fundamental component. This is fundamental component. So fundamental component, so omega drawn the, here is the, you can see the maximum value is 2ic by pi, so it has a 2ic by pi. The third term, here you can see the third harmonics, 3 omega. So here is 3 omega, on that maximum value 2ic by 3 pi has been drawn. So this is how we draw a frequency spectrum. Now the question is, can DC value less than the fundamental? Can DC value be the less than fundamental? Yes, DC value can be less than fundamental sometimes. Yes. Understand?
Yes.
So we can see that the fundamental component is lesser than, higher than the DC component. Okay, it depends on types of signal. Depends on types of signal. From that we can draw the frequency diagram, and from the frequency diagram it is visible clearly that the trend of the signals are getting down according to the frequency highness. All right.
Yes, sir.
So everybody clear about the frequency spectrum?
Yes, sir. Hello, sir.
Hello, sir.
Question? Do you have any question on frequency spectrum?
Sir, if you question said that if you said that find the frequency spectrum of the following square shape, that's why we only write this thing.
Yes, only write these things. But if I ask you in the exam, then you need to do from the A0, AN, BN.
Yes, sir.
Understand?
Yes, sir.
You have to do the Fourier series analysis and then draw the frequency spectrum.
Okay, sir.
Yes, sir. On a full map.
Good, sir.
Yes, full map. You have to do full map. Since this is the known signal that we have done last two slides, I have written directly this series.
Yes, sir.
So in your case, in the exam, you have to do the full maths. Okay?
Okay, sir.
Hello, sir.
Clear, right? Then we can move this one. This is another problem practice. You have to practice this problem where the square wave AC signal given. Till now we have done square wave DC signal. Here is AC signal. And the circuit is RLC circuit. So you need to find out the output voltage, 5 components of the output voltage figure B in the steady state when frequency of the square wave input signal as shown in figure A, 60 Hz. Question is also draw the frequency spectrum for the output voltage components.
Yes, sir.
Can you try now? Or you want to submit tomorrow?
Okay, sir.
Submit tomorrow, okay? I will check one by one tomorrow.
Okay, sir. So one thing. So
Yes.
we can find that AN or 0 here.
Yes, you can use those formula to find anything, A, B, and B0, whatever.
Okay, sir.
new signal, so you have to follow all of the procedure.
Sorry, in previous net, sir, there is no some negative value, sir. So negative square.
Yes, in this case has negative value. So what is the problem?
No problem, sir. Just integration minus
Yes,
20.
and as I mentioned, the AN will be half cycle, so no problem. No problem.
In integration limit 0 to
Change right. 0 to T by 2 is
and
T by 2
T
to
by
T.
2 to T. Yes, sir.
That's the difference. So everybody should show this problem, solution of this problem tomorrow, okay?
Okay, sir.
Yes, sir.
Sarkam Hidul Islam is waiting for class. Few time.
What?
Sarkam Hidul Islam
Tawhidul
is
Islam.
waiting.
Now the another example in different signal. We need to find out the Fourier series. With power strain. So have you seen Saw? Have you seen Saw in your village area?
Yes, sir.
So that kind of signal we need to study. So here, as I mentioned earlier, two major things when you are going to start a signal to solve the Fourier series, to find the Fourier series, that is first you need to understand what is the function of the given signal and what are the limit of the given signal, one cycle limit. It's very important. So if we look at the given signal, that is the sawtooth pulse wave. It is not like previous signal. Previous signal was constant.
Yes, sir.
Previous signal was constant, but given signal is change respect to time. It is increasing and directly fall down, increasing, fall down. But previous was constant fall down, constant fall down. So in this case, the function of the signal is changed. It is not like the earlier. So if you want to find the function of this, then C is dependent on the time. So we have written the y equals to mx, that is taken equation when C is 0. Where m is the amplitude, that means the slope. M is the slope, right? And if you want to find out the slope, then amplitude divided by respective time or displacement. So here x of t equals to t equals to 2. T value is given here 2. So 2 by 2 and that is the, what is the displacement here?
T.
The variable is t. Variable is t. So 2 by 2 into t equals to understand x of t equals to t. So function we had got. Now the limit. What's the limit? What is the limit of the given signal? One cycle limit.
0 to T.
0 to T.
0 to t, right?
Yes, sir.
0 to T. Don't be confused. Don't make it twice T. It is T itself one cycle.
Sir, why we get slope in this math?
Slow.
Yes, sir.
Because
Why we find
the,
that?
can you tell me again what is the problem?
Sir, why we find slope in this math?
Or why we find slope in this time? Okay, so
Yes,
the
sir.
problem is, let me explain you. That is the last problem was so in last problem was like this, right? Isn't it? There is a 0, T by 2. There was T. So if you see that the function here was E, it, it is constant, right?
Yes, sir.
So written the constant is E x of theta. X of theta was written E. There is a constant. But in the given problem is the signal is changes. Signal is changes. So changes occurs, then we need to find out the slope, that what is the rate. Yes, we need to find out the rate of changes. Like if I give you the one example, your destination is Chittagong, okay, and you are riding by bus. So you start from Dhaka and you're supposed to reach to Chittagong. So what is the velocity of the bus? If necessary, how much time required to reach the Chittagong, right? You know the distance,
Yes, sir.
340 kilometers. You know the distance. But how much time? It depends on the velocity of the bus, right? And if you want to find out the velocity, then you need to find out the rate, that your destination is this one. This is the destination of Chittagong here. And how much time take? So destination distance divided by time, you get the velocity. Similarly, our amplitude is 2, and it takes 2 seconds to reach the peak point. So what is the rate of change of the signal? That is amplitude divided by displacement. Find out the slope to find the what is called function of the signal. Do you get your answer or any more question?
No, sir. I understand, sir.
Okay. So we find out the function. Now omega value, omega equals to what is twice by f of t. So twice by t, that is 2 pi divided by 2 equals to 2 to cancel out. So pi radian per second. Angular frequency of the given signal. Now A zero, we use the formula 1 over t 0 to t x of equals to, here t value how much? 2. So we have put the value of t to 1 over 2 0 to 2 t dt. So integration of x dx equals to how much? By
2.
2, right?
Yes, sir.
So that is here. Half t square by 2, 0 to 2. Put in the limit and calculate it, then you would not. So what is the DC value of the given signal?
1.
1. Came all.
Yes, sir.
So if I give you the maximum value is, what would be the DC value? Can you guess? One.
So 0 to 5.
How? And 0?
0 to 5.
DC value. 5 is 5. 5 is amplitude, not the time.
Oh, 5.
So here xt equal, then xt equal divided.
5 divided by 2.
Yes, sir.
1 point something, sir.
2.5, sir.
That means 2.5 t.
Yes, sir.
Yes, sir.
Function is 2.5 t. And you put it here. 2.5 t. So 2.5 is a constant, take it out. 2.5 t. 2.5. Okay?
So result will be
2.5, sir. Result.
2.5. Okay?
Sir, DC value will be all times are half of the given signal, right?
Yes, that's the point that I want to make you understand, that DC value of the given sawtooth wave will be half of the amplitude.
Okay, sir.
That is the message. So in Viva, I may ask for wave. If the amplitude is 10 volt, what will be the DC value? You must answer.
I
5, sir.
Every line you have to think from this line. What is the message from that line? Depth of understanding will be very higher, and you can make the question yourself. And you can answer also. Up to this, clear everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now we have to find out AN. AN is the formula is 2 by T, 0 to T, x of T cos n omega T dt. So 2 by T, okay, 2 by 2, we have given the value of T, 0 to 2. And x of T is the
T.
function is equals to T.
T. Yes, sir.
There is T. After that, you can see here T cos n omega T dt. That means 2 parts of this integration.
Yes.
So we need to apply UV formula. That is called the integral by parts. Integration by parts.
Yes, sir.
That formula is UV formula U integration V dx minus integration du integration V dx whole dx, whole integration dx. Okay, that is formula. Now, which one will be U, which one will be V? That is the critical point.
Yes, sir.
Critical point. If you do wrong, find the solution within short time. It takes long time. Maybe you cannot find solution. That's why whenever you consider, you need to have the practice. So which one is your question? But another very shortly thing that DU, you understand. So if you consider DU, which one will be U that can cancel out? If we consider T, differentiation of T, of cos n omega t. For n omega t, again sin omega t coming, right?
Yes, sir.
T coming, that means you need to do again integration by parts. T, then the already variable is here dt, right? So here with dt. dt. Okay, that's why we consider U equals to T
Is equal to
cos n omega t. Okay?
Sir, we should use the DUET sequence.
So that from this line, if T equals is T 0 to T cos n omega t dt. dt by dt integration dt. Then another tricks that integration is the overall integration, another one is single integration. So you need to give the limit only the outside the integration, not inner integration. Okay.
Okay, sir.
After doing this from this line to this line, T coming inside, because T itself is the variable, T is stable. Understand? 0 to T, whose value? T value. So even T is outside of the integration, but when you give the value of limit, when you give the limit, then you need to take it into inside. All right?
Yes, sir.
Minus 1 over n omega t integration sin n omega t dt. The first part, you can see 1 over n omega t value is 2 sin omega 2. That means here is going to be 1 over n omega. I am writing 2 into sin omega into 2. Write down the 0 part, because whenever you write down 0 as the angle of sine, the total term becomes 0, right?
Yes, sir.
Explain that part. 0 minus 0. Okay. So now omega value how much? Omega is right
Yes, sir.
So sine 2 pi sine n, how much? 0. Sine 2 pi how much? 0, right?
0. Yes, sir.
Bye. Yes, sir. 0.
So total first term, this first term becomes
0.
everybody clear?
Yes, sir.
Okay, I'm repeating that 1 over n omega 2 dot sine n omega 2, right? That means 2 omega. Can we write n 2 omega? N 2 omega, right? So omega equals to, we have found earlier in the last slide, equals to pi. So sine 2 pi 0. Everybody knows it?
Yes, sir.
Sine twice pi equals to 0.
Yes, sir.
Sine twice pi equals to 0. It is constant always. That the first term becomes 0. Or that's why here is 0. Okay?
Yes,
Second term minus 1 over n omega to sine n omega t. So here is sine nx station. Then always write down the cos nx divided by n, right? Isn't it? I'm writing the formula
Yes, sir.
of sine x equals to dx equals to minus cos x cos nx divided by n, right? So similarly here is minus 1 over n omega, this n omega again coming, whole square. And sine n omega means minus cos n omega t, 0 to t. So overall coming minus 1 n square, and whenever put the 2, what is coming here? Cos n omega 2, that means 2n omega. Plus and cos 0 value how much? 1. So that 1 value is coming. So in overall case, look at twice pi. Cos twice pi value how much? 1, right?
Yes, sir.
Cos. Yes,
Twice pi, that is also 1.
sir.
So the an value 0. An becomes
0.
here. We need to find out Bn. In case of Bn, we are applying the same formula 2 by t 0 to t x of t sine. The only change is here sine n omega t
Yes, sir.
plus cos n omega t d. Here is sine n omega t. Okay. So we are putting value 2 by 2, 0 to 2, t sine n omega t dt. Come here. This line 2 by 2, 0 to 2, t sine n omega t. Here also we need to apply integration by parts. Cos t sine n omega t dt.
Yes, sir.
So t is considered as u. So u 0 to t sine n omega t dt. So t d by dt integration sine n omega t dt and overall dt. So after giving the limit for first term, it is very interesting. Very, very interesting. Look at -1 n omega t value is 2 cos 2 n omega. Here, putting here 2, so 2 n omega.
Yes, sir.
So cos 2n pi equals to how much? Cos n 2 pi.
Cos 2 pi is
2 pi.
uh,
So what,
Cos 2
sir?
pi how much?
minus 1, sir.
Equals to
1, sir.
1, not -1.
It's a 1.
So it becomes 1, okay, this time. 2. So that is -2 divided by n pi. Twice pi. Okay? And is it clear? Everybody
No, sir.
are boring.
No, sir.
If you go, if you feel
No,
bored,
sir.
then problem, because it is this kind of problem necessary patience. Patience and
Yes, sir.
passionate, both are necessary. That means I love to do this math and I am enjoying both
With
necessary,
this next.
both.
Okay, sir.
Because this is a long calculation, patience, you cannot find the solution. The patience necessary in this case. Clear?
Sir, how can I minus 1?
-1.
Yes, sir. -1 by n omega. -1, yes, sir.
Okay. How -1 coming? Okay, very good. Integration sine x dx. What is that? Minus cos x.
Okay, sir.
Right?
Yes, sir. Yes, sir.
So in second term we are keeping it. So in second term you can see the sine n omega t dt. Getting here.
Yes,
So
sir.
minus cos n omega t dt. Integrating the second term, so 1 over n omega whole square sine n omega t 0 to t 0 to 2. So equals to -2n pi cos n twice pi. It is keeping yourself 0 as like earlier, because here will be sine n pi. Whatever pi of sine function, that is always 0.
0, sir.
Yes, sir.
And sine 0 also 0. So second term totally 0.
Can Out.
So Bn equals to minus 2 divided by n pi cos n twice pi. This is the series of this sawtooth wave is A0 minus summation of n equals to 1 to infinity 2 divided by n pi sine n omega t. This is the record. This one will be very easy for you. Instead of this, is 1. Since there is a minus sign, minus 2 by n pi, you can write down
B1.
here.
Yes, sir.
Sir, n key.
Sine omega t minus 1 by pi. How 1 by pi? Because it is coming to 2 pi.
Yes, sir.
So it is coming 1 by pi.
Here B,
Okay.
B3.
Yes, minus 2 by 3 pi sine and so on. After the nth order harmonics. Do you understand?
Yes, sir.
Yes, sir.
Okay. I am giving you 5 minutes to think. If you have question, you can ask me.
Sir, I have one question, sir. Hello, sir. Hello. Hello, sir.
Sir, মনে হয় না স্যার স্যার ব্রেকে গেছে।
No, what happened?
ও স্যার
Any question?
Sir, hello, sir. Are you
Yes.
listening? Hello, sir.
Yes, tell me.
Sir, PBS plus, sir. PBS page, sir.
This slide.
Sir, এখানে sir AN equal to integration 0 to 2, sir. Sir, next line, sir. 1 by NW, N omega. Sir, niche, sir. Sir,
Next slide.
sir, niche, sir. Sir, niche line. This, sir. Sir, T dot sine and T, sir. Yes, sir.
To sine NT. Yes, T sine NT. Sine n omega t.
Sir.
Yes.
So how come T dot?
How can T dot? I explained that is the outside of the integration, right? By formula.
Yes, sir.
When you give the value, whose value? 0 to T, whose value? T value.
Yes, sir.
0 to T is the T value. Like if I give you one example, okay? Just it is an example. The example is that you are getting married. Understand?
Yes, sir.
But your father is not getting married. You are getting married. That means you are the function person. But your father is the organizer.
Yes,
So
sir.
whenever function at your home, so your father should be always there.
Okay, sir.
Similar happened here. T, whose their value. You give the limit of T, so we need to keep inside the, understand, Suvarna?
Yes, sir.
That's why T dot sine n omega has been written.
Okay, sir.
Variable of the given problem.
Yes, sir.
Any more question?
Sir, the dt by dt. So
dt by dt.
dt by dt,
Differentiation
sir,
of T,
sir, n by 2, sir,
1.
n for 2. So cutting
Divide
out.
divide dt into T. Differentiate of T. That's mean 1.
Here, look at formula. Look at the formula. You don't need to remember the formula.
Yes, sir.
Remember formula. du by dx. What is u?
1, sir.
So dt. And x is here. Your problem is x. T is the variable in our problem. X is the variable. Understand? T is the u, and this is the formula. Differentiation formula. D by dt. I am recommending you to do the math by yourself, by hand, not by brain. By hand doing is important. If you don't do by hand, answer the question correctly in the exam. I can write for you. So practice at home.
Sir, someone is waiting for joining.
Someone waiting. Jim, why is so late? Jim,
Hello, sir. I had a class 9 to 10. Then, sir, somehow I fall asleep, sir. That's why I became late, sir. I woke up from 10:30 a.m. Then I asked to join 4 or 5 times, but I was waiting, sir. That's why I got late. 1 hour. Sorry, sir.
when I give you the, I cannot change the slide again and again. Not
Yes,
change
sir.
the
Yes,
window again and again.
yes, sir. That's why. Okay.
So all of you have seen the last.
Sir, sir, previous slide, sir. I have a question. Sir, previous slide. Yes, sir. Sir, minus 2 by n pi. Last line, sir. Yes, sir. Cos pi plus 0. Sir, now cos 2 pi equal 1, sir.
Yes.
But n, why, sir? Minus 2 by n by pi. But why, sir, n?
Oh, okay. The reason behind it, okay. N, right? Your problem is N. Where is N?
Yes, sir.
Is 1, then what? Cos 2 pi. Okay. Cos N value 2, then cos 2 into 2 pi, right?
Yes, sir.
Isn't it?
Yes, sir. Yes, sir.
Oh. So still it is 1.
Okay, sir. Thank you, sir.
Okay.
Yes, sir.
Say 2 pi means 360 degree.
It's 1, sir.
Going to be 720 degrees. So cos 720 degree also 1.
Yes, sir.
Okay.
Hello, sir. Hello, sir. If
Yes,
we
tell me.
use in sir sine wave, then sir that has no constant value. Then sir, what we have to do?
If you give sine value,
Sine wave, sir. যদি এটা sine wave থাকে স্যার তাহলে স্যার আমরা
sine wave.
Yes, sir. তাহলে স্যার আমরা কি করব স্যার? কোনো
So we
constant
have
value
that problem. Yes, that is not constant value. Then we have to give the what is the function of sine wave. Sine wave. Can you tell me?
Sir, I don't know, sir.
Can you tell me what is the function of sine wave?
No, sir.
Then what is your semester now?
Sir, 11.
And you don't know the function of sine wave.
Sir, I can't
Oh my
remember right
God.
now, sir.
It is not the matter of remember, it is matter of understanding. If you understand, you can remember whole your life. If you don't forget. The very important thing is that you are electrical engineer and electrical major signal is sine wave, sine. Our utility line also sine. And you have studied the circuit 2. In an AC signal, you have used the sine omega t. Have you used Bm sine omega t or A sine omega t, A sine theta? Have you used?
Yes, sir.
So the sine wave, look at the board. If it is called theta, so its function is maximum value. So Bm sine theta. Have you done this kind of math? Two?
Yes, sir. Circuit 2, sir.
I think so. Transformer.
So circuit
Yes,
2,
sir.
So you have
BM,
Yes, sir. Yes, sir.
BM sine omega t.
Ask you the name of the signal.
So sine wave.
right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
It looks like sine wave, but it is not sine wave. Wave. Cos wave. Sine wave. But sine 90 plus theta. Sine 90 plus theta, what is that? So this is a cos wave, cos wave. This back to the basic formula, basic wave.